As you know, ATC's job is to keep airplanes from running into each other. Back in the old days when we were flying Cessna Airmasters and driving DeSotos, ATC was doing its separation job by using altitude and time. They knew your true airspeed, it's on your flight plan, and they would not clear another airplane on the same route until there was sufficient interval between you and them. Since changing conditions can affect such time-distance calculations, ATC's intervals had to allow a little extra margin for safety. Of course, you can imagine that holding played a bigger role back then. But when the airlines moved from pistons to jets, the system clearly needed more efficiency. The answer came with radar. Instead of looking at clocks with sweep second hands and writing times on cardboard strips, ATC could now see exactly how much space there was between each airplane, and they could control it. It brought air traffic control into a new era. Early ATC radar installations were identical to military search radars. They located aircraft by sending out a pulse of radio energy from a rotating antenna. When that energy hit the skin of an aircraft, part of the energy was reflected back to the radar's antenna. Your position was displayed on the operator's radar scope as a blob of light. The system of using radar reflection from the skin of an aircraft is called primary radar, but you may hear controllers refer to it as skin paint. But primary radar has limitations. For example, one blob of light on a scope looks a lot like another blob of light. Controllers needed a way to identify each contact they saw. So they used techniques such as asking a pilot to report his position based on the pilot's own navigation, or they would ask for a turn, which they could see on the scope. Another problem is that the primary radar display is two-dimensional. Two airplanes could be over the same piece of Earth, and to the controller, it looks like they're going to collide, even though one may be several thousand feet above the other. So it's into this scenario that the transponder rides in on a white horse to usher in the concept of secondary radar. The system works by sending out an interrogation signal to your transponder, which replies by sending back your squawk code and altitude. The system knows that the squawk code belongs to you and displays your aircraft position on the radar scope, along with your N number, aircraft type, and altitude. It even calculates and displays your ground speed. Although a transponder doesn't send out a very strong signal, it's much stronger than the reflected energy the primary radar gets from the airplane's skin. So the controller will be able to see your airplane in situations where he couldn't with only the primary radar. The primary radar system is still in place, and ATC can usually see you without a transponder. But things go a whole lot better for everyone if you do have a transponder, and it's working. Having a working transponder greatly increases the likelihood of your hearing those magic words, radar contact. But just what do those words mean to you? When the controller tells you that you are in radar contact, it means two things. One, he has identified you on radar, and you'll get traffic advisories on a workload permitting basis, which is sometimes known as flight following. And two, you are no longer required to make mandatory position reports. We'll talk about position reports in just a little bit. But just because ATC is following you on radar doesn't mean that you'll be kept separate from all other aircraft. Remember, those advisories are on a workload permitting basis. If you're flying in good weather, you'll probably be sharing the skies with a bunch of VFR guys. And depending on the class of airspace you're in, many of them may not be talking with ATC, and the controller may be too busy to point them all out. In fact, some of those VFR folks may not even have transponders, so your controller might not even see them at all. So even if you are IFR, when you can see out the window, the old adage of see and avoid is still the rule of the day. Now, what happens if you haven't heard the magic words radar contact, or ATC tells you radar contact lost? Well, first of all, you may correctly assume that the controller can no longer see you on his screen. And that means that, one, you'll no longer be getting traffic advisories. And 2, you'll have to make position reports each time you cross a mandatory reporting point. As you remember, those are the fixes that are marked with a solid triangle, or any fix that defines your route. So what do you say when you're making a position report? You call the controller and you tell him the fix you're reporting over, the time you are over that fix, your altitude, the name and your ETA to your next reporting point, and finally, the name of the reporting point after the next. A way to remember this is with the mnemonic PTAEN. That stands for position, time, altitude, estimate to the next reporting point, and the next reporting point after that. If you're relaying your position through a flight service station, you'll also need to tell them whether you are on an IFR or VFR flight plan. You don't often get a chance to make position reports these days, but you'll want to remember your PTAEN for those rare occasions when you are not in radar contact. Now, let's go back to the modern world and talk about what happens when you are in radar contact. As we discussed, when you're on an IFR flight plan in radar contact, ATC will point out traffic to you. Normally, it will be VFR traffic, since the controller is already separating you from IFR traffic. The controller has no idea, just looking at his scope, whether you're in the clear and can see, or are in the clouds. But with his call, he's going to give you an opportunity to visually find the traffic. Now, when ATC calls out traffic, they use the familiar clock code. But there's a gotcha here you need to remember. The controller considers 12 o'clock to be directly ahead of your ground track on his screen. If you're holding any crab angle to correct for the wind, and when aren't we, the controller's view of 12 o'clock and your view of 12 o'clock aren't going to agree. So you'll need to add or subtract your crab angle. For example, if the controller said that you had traffic at 10 o'clock and you had a 20-degree right crab, you should initially look 80 degrees left of your nose, 30 degrees for each point on the clock plus the 20-degree crab. Now, since these angles aren't measured in a laboratory, it's a pretty good idea to scan in the whole quadrant of airspace once ATC has given you a traffic report. Incidentally, the correct response to a traffic report is either traffic in sight or negative contact. Using standard terminology eliminates confusion. Now, when ATC says that you're in radar contact, they're providing IFR separation, but you still have full responsibility for your navigation. On the other hand, if ATC gives you a vector, then ATC is, at least temporarily, taking responsibility for your navigation. In most cases, radar vectors result in your joining a published route or procedure where you again pick up navigation responsibility, a fact that ATC makes clear with resume own navigation. At times, ATC will give you vectors and assign you an altitude that's below the MEA or MOCA for a nearby airway. ATC can do that because they've divided their area radar map into sectors and established minimum vectoring altitudes for each sector. Since those sectors cover smaller areas, they can often safely allow for lower altitudes. But those minimum vectoring altitudes still guarantee the same obstruction clearance used for airways. That's 1,000 feet above in non-mountainous areas and 2,000 feet in mountainous areas. By the way, you won't find the minimum vectoring altitudes on any charts you have. The radar controllers do have them, though, and if you're ever curious or worried about the minimum vectoring altitude where you're flying, just ask. Now, here is another case where you shouldn't be complacent. When ATC is giving you vectors, they are not only in charge of your navigation. Since you're no longer on published routes, they are also in charge of your terrain separation. And just like everybody else, controllers occasionally have a bad day. So while you're being vectored, it's a very good idea to keep track of your position and the height of the terrain around you, just to make sure the controller doesn't make a mistake. That's why we recommend that you have VFR charts out and use a GPS if you have one to help keep track of your position. Here's another warning. Don't expect the controller to use his radar to guide you around storms. ATC radar doesn't show precipitation nearly as well as airborne and National Weather Service radars that are designed just for that task. ATC radar is designed to depict traffic, not weather. So just because a controller says that he doesn't see any weather in front of you on his screen, it doesn't mean that it isn't there. For information about storms, ask the controller if he has any PIREPs and call FlightWatch or the nearest flight service station. As you can see, radar has evolved into a powerful tool to help you and the controller keep airplanes separated. And everybody likes that.